EV-Friendly returned to Precision Auto Service in Langley, BC, this time to witness the removal and repair of a Tesla drive unit. The subject vehicle is a 2014 Toyota RAV4 EV, which is equipped with a drivetrain built for Toyota by Tesla. There are some subtle differences between these units and the ones Tesla puts in their own cars, which we will describe a little later. The customer complaint was a whining noise while driving. It was particularly noticeable when pulling away from a stop. EV-Friendly rode along on a test drive and recorded the noise. You can just hear the high-pitched whine over the road noise. Precision Auto Service recently had another vehicle with the same problem, but the noise was a little different and louder. These noises are caused by worn-out bearings in the drive unit. What typically happens is that a coolant seal fails. Coolant gets into the bearings and washes out the grease, which quickly causes the bearings to fail. Removing the drive unit is fairly straightforward. The technician just needs to take extra precautions necessary to protect against electric shock. The first step is to disconnect the 12-volt battery. Next, the technician removes the high-voltage system's safety disconnect plug, located beneath the front passenger seat. He pulls back the carpet to expose the cover, which is held in place by 4 nuts. With the nuts removed, the technician removes the cover plate, exposing the safety disconnect plug. He pulls up on the black locking bar to release the plug and lifts it out. The technician will later verify that the voltage has been isolated before touching any high voltage components. With the vehicle lifted on a hoist, the technician removes the front cover plates. Now we can see the drive unit. It is located where the front-wheel drive engine and transaxle would be located on a gas-powered model. Here's one of the differences between the Tesla drive units and the ones that they build for Toyota. Beside the Tesla logo, there is a VIN plate. If the VIN on this plate matches the vehicle's VIN, you know that this drive unit is the original that was installed in the factory and not a remanufactured one. There are several cross members that must be removed. Now the technician drains the oil from the unit by removing the drain plug. Next, he disconnects the coolant hoses to drain the coolant. This is the speed sensor. The technician removes the speed sensor and inspects it for signs of coolant or oil leakage contamination. When the sensor is removed, he can also look through the hole for signs of leaks. As mentioned earlier, a common problem is that the coolant seal has failed. If it has, there will usually be evidence of coolant inside the speed sensor mounting hole. Now it's time to remove the front axles. The orange cables are the main high voltage lines. Earlier, we mentioned that the technician will verify that the HV system is isolated to the battery and no voltage is present here. He does this by removing the orange plastic cover plate to expose the terminals. He touches the probes of a voltmeter to the terminals. We can see that there are 0 volts and it is safe to work on the HV components. There is still some coolant that is not drained, so the technician blows compressed air into one of the hose outlets to push it through. With the help of another technician, he removes the front crossmember. There are a few nuts and bolts to remove from above the unit, so the vehicle is lowered on the hoist for access. With the vehicle raised again, all but one of the bolts securing the drive unit are removed or loosened. Now it is time to place the powertrain lift table under the vehicle. Having done this before, the technician has saved some blocks of wood that are just the right size and shape to support and stabilize the drive unit on the table. The final bolts are removed. The technician carefully lowers the unit away from the vehicle. And here we have the drive unit assembly, removed from the vehicle. The unit is made up of 3 components. The cylindrical component on one end is the inverter. The one on the other end is the electric motor. In between is the transaxle, which contains the single-speed gear reduction transmission and differential. Here you can see a Tesla label, and here's a Toyota label. Some of the case screws are covered with tape with the warning, "Warranty void if removed." Here is another difference between the Toyota units and the ones Tesla puts in their own vehicles. The Toyota units have a parking pawl, whereas the Teslas do not. This is the parking pawl actuator. Before he can start disassembling the unit, the technician must secure it to an engine stand. First, he cleans the threads of the bolt holes, where he will attach a plate and lifting chains. He aligns the plate arms with the threaded holes in the drive unit and secures the bolts. With the chains now attached to the plate, The forklift's forks are positioned above the unit. The second technician holds one end of the unit while it is lifted off the table with the forklift. This prevents the unit from tipping due to its uneven weight distribution. The technicians tilt the unit to the approximate angle it needs to be before attaching the engine stand. They move the stand into place and secure the drive unit to it. Now it can be lowered and the chains can be removed. The technician uses brake clean to clean the unit so no debris enters the unit when the cases are removed. A catch basin is placed on the floor to capture the fluids that drip off the unit. After the unit is cleaned and dry, he removes the inverter case screws. He gently lifts the case off of the inverter. As you can see, the inverter contains multiple circuit boards and other electronic components. None of these internal components are available as replacement parts. However, failures are very rare. Many EVs have the inverter as a separate component rather than integral to the drive unit. The technician explains the basics of how the inverter works.
From here to here is all the inverter, part of the drive unit. That's the low voltage connection. The high voltage comes in, bolts to here. The three boards turn it into AC. It goes down through here to the bus bars to the motor.
The reason the inverter case was opened is because there is a wire for two temperature sensors inside the motor section of the drive unit that run around the base of the inverter and through the transaxle to the motor. This wire must be freed up before the inverter can be separated from the transaxle. The technician cuts some zap straps and carefully removes the wire from where it is seated. The small orange cover between the motor and inverter is for the three-phase connections between the stationary windings of the motor and the inverter. The technician removes this cover. One bolt is removed from each phase connection. Now the technician removes the screws where the inverter mounts to the transaxle. With the help of the second technician, the inverter is lifted off the transaxle. You can see why that wire had to be freed up. Now we see inside the transaxle and its shafts, gears, and bearings. The technician identifies the bearings that he will be replacing.
Well, there's one in there, but there's this bearing in here.
Oh, yeah.
And then there's a bearing on the other side of this shaft in there that I'm going to replace. The one that rides here, which is inside that case. Then the other two are inside there.
He begins removing bolts holding the internal parts in place. He gently taps from the underside and frees up the differential. This is the oil pump gear. The technician explains how the oil pump works.
It's driven off the differential, and it sprays the oil out here onto this bearing, sprays it out here onto this gear in here, and it also pumps it into the case, into this bearing in here, and forces it through this bearing. That's just to help extend the life of these bearings, because these bearings are also spinning up to 18,000 RPM. And they aren't exactly rated for that kind of speed. So by forcing the oil through it, they can help make them last longer at those kinds of speeds.
He removes the oil pump. There are two shafts with gears and bearings, the input shaft and the intermediate shaft, and the differential with the ring gear and bearings. The technician removes these. The unit is tilted to drain the residual oil. And then the technician cleans it. Turning to the motor, he removes the speed sensor. He had temporarily removed it earlier and inspected it, and put it back, but now he removes it again to keep it from being damaged. He removes an external coolant pipe. Then he removes a motor mount. how he removes the coolant manifold. The seal that typically fails surrounds the pipe you see here. The technician explains.
So that sensor I removed, it uses all these teeth to figure out how fast it's going. The seal leaks on this shaft, so it gets out into this compartment. And then this compartment has a hole right here that's a vent. Inside that opening is a vent hole in there to allow pressure balance between this end and the inside of here. Then these wires here for the motor are open to the inverter. So what happens is it leaks, it fills up here, it makes its way into here, it fills up the bottom, gets past these and into the inverter. So it takes a while, but
It actually fills up inside the electric motor?
I've seen videos of people pulling that orange cover off the inverter and it just pouring like a couple liters of water out. Like it has to get really bad by then, but I've seen it.
He removes the speed sensor gear. Next, he removes the motor end cover. The bearing here is one that he suspects is the noisiest. The rotor is removed so that the bearing can be replaced. Here's the inside of the motor. All of the bearings will be replaced. The technician explains how the parking pawl works.
That's the parking pawl mechanism. That's what engages with this gear. It's like that. So it's in park right now. So that would be when it's in gear. That's it, free spin.
There are bearing kits available, but they are expensive. Precision Auto Service orders individual replacement bearings from a bearing supply company, using the numbers found on the bearings. Besides the bearings, there is one additional part that will be replaced. There is a modified coolant manifold available that eliminates the seal that typically fails. The technician explains.
This is the old one. This is the new one. So, coolant in, speed sensor hole, coolant out. But instead of having this pipe, the coolant here goes this way, up, bypassing it, and just out the top. So that eliminates the seal here. Makes it a lot more reliable.
The bearings are replaced in the standard way, using a bearing puller and all related tools. The unit will be reassembled and reinstalled in the reverse order that it was removed and disassembled. Precision Auto Service is presently one of very few repair facilities that have invested in the tools, equipment, and training necessary to diagnose and repair high-voltage batteries and other EV components. This too will change as shops start to see a larger portion of their customer base driving electric vehicles.